This is Thomas Froese of the University of Victoria Department of Civil Engineering, and I'll be talking about our work to develop a sustainability-centered design curriculum in civil engineering. This work makes up what we call a sustainability-centered design spine that runs through our program. We'll start with some background. Civil engineering is a fairly new program at UVic that was conceived in 2012 as having a particularly strong focus in green civil engineering and also in active learning. So the program started in 2013, and after several years of building up the program and the new faculty, a retreat was held in 2016 where it was decided that they would have a particular focus in problem-based learning. This led to a faculty hire in 2017 with PBL expertise, and a following department retreat in 2018 where it was decided that the strategy for PBL was to create a design spine that runs throughout the 4-year program. So I'll briefly describe the design spine approach. This is a map of our curriculum across our 4-year program. And the design spine involves one major design activity in each term. These design activities are integrated into the existing course structure, and in each term, one course will act as the main host for the design activity with several other supporting courses, and then the content about sustainable design will ladder or build across the whole program. A few comments about the format of the design activities. They're designed to avoid some of the pitfalls that are common of large group projects like massive workloads at the end of the term by adopting some of the principles from team-based learning approaches. So instead of one massive submission at the end of the term, they generally have multiple smaller deliverables that enforce collaboration within the group instead of splitting the work up into individuals and all working separately. The assignments tend to start in the middle of real-world design project scenarios, rather than starting with a blank sheet of paper. So this enables students to be involved in multiple design cycles at meaningful levels of detail within a reasonable amount of time. And the projects also include some reflective or metacognitive assignments. Now we'll touch on some of the content that we're including in the sustainability design spine. We think of this as a focus on sustainability-centered design. So sustainability is at the heart of the design. It's not just some additional requirement that's tacked on somewhere within the design process. We're trying to draw these ideas from user-centered design or design thinking, which places users at the center of the design process, but here we're focusing on sustainability as a central driver to the whole design process. So we followed our previous steps towards creating a design spine with an undergraduate research project in the summer of 2019 that worked on gathering up and organizing a lot of the sustainability and design content or ideas that we wanted to incorporate into the design spine. The summer project collected a wide range of content about both sustainability and design that we wanted to include in the design spine lessons, and we spent quite a bit of time finding ways of organizing it. In the end, we landed on this framework that we found worked well as a fairly simple structure that could position all of this content, and it had the same basic approach for both sustainability and for design. In both cases, there are some background concepts necessary. In some cases, these are already common in engineering programs like math and basic sciences, but in other cases they are less common, like ecology and biodiversity. Then, there are conceptual frameworks, or basic ways of thinking about and approaching design and sustainability projects, like process models, system science, and life cycle thinking. Then, there are a wide range of specific tools and techniques that can be brought to bear on both design and sustainability. And finally, there are many different application areas where sustainability and design can take different specialized forms. Following on from this project, I taught a 4th-year elective course on case studies in sustainable design, where we spent a lot of time discussing sustainability and the design process at a somewhat abstract level, and then looking at case studies that dealt with these issues in real-world projects. Students collaborated to develop their own frameworks and case studies, so it provided an excellent opportunity to find out which ideas seemed to resonate and stick with the students. These turned out to be several of the conceptual framework ideas describing the design process and many of the specific design tools and techniques, as well as some of the sustainability tools and techniques. It was harder to find common understandings of overall sustainability frameworks. Based on these outcomes, we developed a series of video lessons that presented these sticky ideas. These included an introduction to design, the idea that design is a process made up of a series of activities. And there's many different types of activities that can be put together in different ways. So that essentially creates the idea of a design toolbox. And a closer look at many of the specific types of design activities. And some of the patterns for how these design activities can be organized into an overall design process, like the waterfall model, or divergent and convergent thinking, or iteration loops, feedback cycles, or phase gates. Next, I'll touch on how we've started to implement the design spine. Our second-year core course, Sustainability in Civil Engineering, has introduced a design project to design a sustainable community. Previously, the course looked at sustainability concepts and technique, but it didn't have a particular focus on the application of these ideas to engineering design. So now, there's a series of assignments throughout the course that collectively form this design activity, and they specifically reference a design process model. There's activities to generate multiple alternative design solutions, a series of activities to carry out different sustainability analysis of the different alternatives, an activity to then compare the different alternatives on the basis of these analyses and make a recommendation, and an activity to reflect on the overall process, tie the ideas into what they're learning in other courses, and compare the students' experience of this design with the design process theory that they've been learning about. Finally, I'll touch on some of the more recent steps that have followed on from our design spine activities. In a different recent curriculum project, another one of our faculty, Tom Gleeson, developed a nice analogy of our design spine approach and has been thinking about design as providing the central spine of our program, but that a spine alone isn't sufficient. And sustainability provides the muscles that support the design bones, but the muscles don't function unless there's a blood supply. And equity, diversity, inclusion, and anti-racism provide the heart of sustainability and human-centric design. So his project is looking at how we address anti-racism in our program. And he's doing this initially by extending the strategy from our design spine work of making explicit learning modules that get layered onto the various technical courses and that span across the entire curriculum. He's identifying the existing or potential content and helping to flesh out short but explicit lesson plans for where we cover design in the program, where we cover sustainability in the program, and where we cover EDI and anti-racism in the program. We're also extending these ideas further to tie into our overall accreditation and continuous improvement process. Our accreditation requires that we address 12 graduate attributes, and they are all treated equally by the accreditation process, but really they divide into two different groups. Graduate Attribute 1, a knowledge base for engineering, is where we place much of our teaching focus, and here the curriculum is very explicit. Explicit learning outcomes, explicit content and material delivery, explicit student activities, and explicit assessment. It's the basis by which we structure most of our courses. We also address the other 11 graduate attributes, but often it's implicit in the program, and it's usually incorporated into the courses that are structured around the knowledge base graduate attribute. So the technique that we're using in the design spine, and that we're moving towards across the entire range of graduate attributes, is to try to ensure that all of this learning is explicit curriculum rather than implicit. It's still integrated into the technical courses and topics, but we only count it if we've defined explicit lessons for the subject. So in our current accreditation process, we define indicators for the graduate attributes, and we map all of these to course learning outcomes. But it's quite complicated, no one likes the process, and there's the sense that it doesn't do much to change the curriculum. Instead, we could use the approach that we only count material that has explicit modules and lessons. We define these lessons to cover all of the engineering skills graduate attributes, and we map these onto the courses, still organized mostly around the technical knowledge base, to create this matrix curriculum. Delivering these lessons would achieve our accreditation tracking without the need for a separate process.